Hello, welcome to this video. My name is Ashimole Ikechukwu Emmanuel, a mathematics tutor. In this series, we'll be looking at universal sets, complements of a set, and difference of sets. These are the objectives of this lesson. Let's go to universal set. Stay tuned. The universal set, denoted by the symbol, or sometimes is denoted by this symbol. So the universal set is the background set which contains all the elements being discussed. It is the background set which contains all the elements being discussed under smaller sets. What do I mean? Now, if you have a set A to be equal to 1, 2, 3, 4, a set B to be equal to 5, 6, and 7, a set C to be equal to 8, 9, and 10. So how do we find the universal set? How do we find the universal set? So to get the universal set, we say that it is a set that contains all the elements. It is a set that contains all the elements being discussed under each smaller set. This is a smaller set. This is a subset. This is a subset. This is a subset. So universal set must contain all these elements. Okay, so if it is containing all the elements, so what is now the universal set? Since there's 1 in A, even though there's no 1 in B and C, but since there's 1 contained in one of the sets, you write 1 down. Since there's 2 contained in one of the sets, you write 2 down. So you're having 1, 2, 3, 4, up to 10. Okay, this simply means that there is 5, there is 6, there is 7, there is 8, there is 9. So the universal set contains all these subsets put together. When we have a set P, the complement of this set P is denoted by the symbol P prime or P raised to the power of C. The complement of a set P is denoted by the symbol P prime or P raised to the power of C. The complement of Q is denoted by the symbol Q prime or Q raised to the power of C. So what is now complement of a set? Complement of a set is the set of all elements which are present in the universal set but not present in the set itself. All elements present in the universal set but not present in the set itself. What do we mean? Now, if we have a universal set, for example, we have a universal set which is from 1, 2, 3, going to 10, we have a universal set which is from 1, 2, 3 going to 10, and we have set A which is giving us 4, 6, and 8. We have set B which is giving us 2, 5, and 7. So if we are asked to find a complement, how do we find a complement? A complement simply means the element you can find in the universal set. This is the universal set. The element you can find in the universal set that you cannot find in A. So what are the elements you can find here that you cannot find in subset A? You can find 1 here. There's no 1 here, so 1 is inclusive. You can find 2 here. There's no 2 here, so 2 is inclusive. We have 3, we have 5, we have 7, we have 9, and we have 10. So A complement is equal to 1, 2, 3, 5, 7, 9, and 10. Now, if we are asked to find B complement, B complement simply means what you can find in the universal set that you cannot find in B. So what can you find in the universal set that you cannot find in B? 1, 3, 4, 6, 8, 9, and 10. So B complement is 1, 3, 4, 6, 8, 9, and 10. So basically, complements of a set are the elements you can find in the universal set, but you cannot find in the subset. Given any two sets, A and B, we have two sets A and B. The difference of these two sets is the elements we can find in A but cannot find in B. The difference between these two sets are the elements we can find in A but they are not contained in B. So those elements are found in A but they are not contained in B. Now, if we have set A to be equal to 4, 5, 6, 9, and we have set B to be equal to 6, 9, 10, 11. So how do we get the difference of these two sets? Difference simply means that what you can find here but you cannot find here. But before we solve this, I want you to note that to get the difference between A and B, it is denoted by A minus B. Okay, so A minus B is the element you can find here but you cannot find here. So what are the elements? 4, 5. I think 4 and 5 are the only elements because there is 6 here. We can find 6 here. There is 9 here. We can find 9 here. So we're having only 4 and 5. Mind you, we are asked to find A minus B. So A minus B will be the element we can find in A, but we cannot find in B. Now, what if we are asked to find B minus A? How do we get B minus A? The elements we can find in B, but we cannot find in A. What are the elements we can find in B? but we cannot find in A. I think there is 6 here. There's also 6 here. There's 9 here. There's also 9 here. 10 and 11. We can find 10 and 11 in B, but we cannot find 10 and 11 in A. So the answer is 10 and 11.